this is bus schedules, and like all these come from Advent of Code, although I've modified some of them somewhat. So the idea here is you need to catch a bus. You're at a bus stop and there's several different bus lines running. Each bus has a different schedule and ID number. Now the way it works, all buses launch the bus at time equals 0, and their ID number indicates how long it will be before it comes around again. And they just repeat. So the bus with timestamp with ID 5 will be here at 0, it'll be back again at 5, 10, 15, and so on. The bus with ID 11 will be here at 0, 11, 22, 33, and so on. And immediately, I think what we're doing here is we're learning Aristides' sieve to find prime numbers, which is essentially what you're doing. This is how people have found prime numbers, and we're basically doing the early beginnings of efficient prime number finders. So the input data consists of 2 lines. The first line is the earliest timestamp you could depart on a bus. The second line lists the bus IDs that are in service. And entries with an X are out of service. So here's some data. Let me zoom in on it. All right. So here, I'm starting at time 0, but I'm not going to be available to catch the bus until time 9:39. And the buses are 7, 13, 59, 31, and 19. And you ignore the X's for now. Notice all these are prime numbers. They're always all going to be prime numbers. If they weren't, bad things would happen. So now I want to find out what is the first bus I can catch after time 9:39. I don't care which one it is, but I want to figure out which one it is. So here's the timestamps near 9:39. Bus number 7 will hit at 9:31, and then 9:38, and then 9:44 every 7 minutes. Bus 13 will hit here. Bus 59 will hit down there. Bus 31 and bus 19 will hit there. So if I'm working at 9:39, the next one I can catch looks like it's this one here, bus 59 at 9:44. That's the next bus that's coming, and that's what you want to do to predict that number. And it'll be 5 minutes before it departs. So you got some input data here, but a lot of these X's. But again, notice all the numbers are prime. And a couple of them are really big, 523 and 787. And you want to find the bus number, the earliest bus to take, and the number of minutes you'll need to wait. Now, the thing which I found was very interesting is simultaneous departures. And the trick here is you can combine routes. So if you have 2 buses, now that'll come in the next one. So here, after you do that, that one's pretty easy. That's just modular arithmetic to solve that one, really. But the next one is more interesting. You want to find a time when bus 5 departs and bus 7 departs 1 minute later. The first such time is going to be at timestamp 20. The next time it happens is at timestamp 55. Because if you think about it, timestamp 20, 5 will depart. That's an integral multiple of 5. And 21 is an integral multiple of 7. So 5 will depart at 21 and 20, and 7 will depart at 21. Now 55 is a multiple of 5, and 56 is a multiple of 7. So it will happen again. So it's going to happen every 35 minutes. And the reason is because you can take buses with routes 5 and 7, and you can effectively combine them into one bus with number 35. Every 35 minutes, the whole pattern will repeat. And that applies to all of them, and that is why I say it's particularly relevant to today's lecture. You can take a list of n buses, and you can merge 2 of them into one bus and shrink it to a list of n minus 1 buses. So you can make a recursive function that will simplify the problem by 1 bus, and then call itself again to simplify it by 1 more bus and 1 more bus and 1 more bus, until they're all boiled down to 1 bus, and then you get the answer. And that's a logical way to do it. So anyway, here's one with 3 in order, and here's another problem here, and there's one here where now you find out what the X's are for. The X's are minutes you're allowed to skip. So this one comes in at time 0. This is 1 minute later. 2, 3. This is 4 minutes later. 5, 6 minutes later. That's what all the X's are for. So they're not strictly in order. There's time gaps between them, denoted by the number of X's, which is all pretty simple. Anyway, so there's a variety of flags to find there, and as you see, you get a lot of extra credit points if you do the more complicated ones, which do get pretty bloomin' complicated. Anyway, that's what I wanted to show you. And the whole idea here is that beginners should be able to solve the first flag or 2, and experts should find in the later flags something to keep your interest up. And let me know how you like it. Let me know if how it works out that way. But this is the way all my courses are supposed to be. A beginner is supposed to be able to do enough to get by, and there's supposed to be tough stuff that will amuse experts. And I love the advent of code. Many interesting little puzzles that really are worth thinking about. So That's what I wanted to show you about that one. Let me go to Twitch. Can you double check flag for VP 26.3 is correct? Let me make a note of that. Check. Good, I will. It may be wrong. This is the first time I've written these projects, so there may be mistakes. Let me stop the recording.